Okay, so this is the paper 3 that I'll be working through now. Make sure you check a second method if I give that for some questions, because it might help with a question that might be similar to it but a little bit different. Okay, so you're going to be more equipped to do those kind of questions. So question 1, simplify x to the power of 5 squared. Now they don't give space for working out, but we can write things here. So we know x to the power of 5 squared is x to the power of 5 times x to the power of 5, and then I know from my indices laws that this is going to be x to the power of 10. Question number 2, what is the sum of the exterior angles of any polygon? Now normally we're taught to find one exterior angle of a regular polygon. We will do 360 divided by the number of sides, and the number of sides is the number of exterior angles that it has as well. So if that's the case, then they must add up to 360. Okay, so 360 degrees. Question 3, the bearing of B from A is 070. Okay, and it's here. Circle the bearing of A from B. Okay, so we're looking for this angle there. Now if I was to extend this line, I can see that this angle here would be 180, and I need to find this angle. Now when you're working with bearings, it's very important to think about parallel lines, because these north lines here are both parallel, and if that's the case, then we're going to have alternate angles here. Okay, so this angle here is alternate with this angle. Okay, so they're both 70. So if that's 70, this is also 70, and this side is 180. So 180 add 70 is 250. Okay, so question number 4, we have y equals an expression here. Circle the expression for y squared. So if I was to square y, I square everything on this side. I'm actually going to write that out. So if I have 5 times square root of x and then 2 here, and I square that, well, that's the same as saying 5 square root of x and then over 2 times another 5 square root of x over 2. Now I can see that my denominator is going to be 4. I am going to have 5 times 5 at the top, which is 25. Square root of x times square root of x is just x. So I'm going to have 25x at the top and 4 at the bottom. So it's going to be this one. Now question number 5, it says Paul won a race with a time of 71.3 seconds. This time t, okay, so they're calling it t now, is to the nearest tenth of a second. So that means they've rounded up to this position straight after the decimal point. Complete the error interval due to rounding. Okay, so when we're finding an error interval, we look at where they rounded up to, and in the next place value we put a 5 here for the upper bound there. So we're going to say 71.35. Okay, and it's always easier to do it this way, to do the upper bound first, and then the lower bound would be 1 less than the 3. Okay, so 3 tenths here, we're going to say 2 tenths. So 71.25. Okay, and now you can actually check. If I was to have 71.26, would that round to 71.3? Yes, it would. If I was to have 71 point something less than this, so 71.31, okay, that would round to 71.3 as well. Okay, so this works. Okay, so question number 6 now. It says these two right angle triangles are similar, and write down the value of tan x. Give your answer as a fraction. Now as these two right angles are similar, the value of tan x would be the same for both of them. Okay, so we're going to have for this angle, that is, so opposite and adjacent there, opposite and adjacent there. 3/4 is our tan x, and here we got y/6 is our tan x. Now they have the same value, so 3/4 is actually equal to y/6 in this case, and making that equation can help you find what y is. Now that's a very important realization that you need to make for much harder questions actually. So for this question, we've got write down the value of tan x, and that is 3/4. Okay, obviously we can't use this because we don't know the value of y yet. So we've got 3/4, and that's simplified. Question B now, work out the value of y. Okay, I've already said one way we could do that. We can make an equation. 3/4 is equal to y/6. But I think most of us, we would actually like to do it this way. We would look at what the multiplication is to go from 4 to 6, and that is multiplying by 1.5. Okay, so this is going to be times by 1.5. And if you're not sure how I got that, the way you get that is 6 divided by 4 gives you 1.5. So I'll write that down. 6 divided by 4 is 1.5. Now, if I know that the enlargement is by scale factor 1.5, this 3 can be multiplied by 1.5 to get this y. So 3 times 1.5 is equal to 4.5. Okay, so 4.5 centimeters here. The other way that I mentioned that we could do it is here. I'll actually write that down. So we could have said that 3 over 4 is equal to y over 6. Okay, so this would be the case when triangles are similar and we're using the corresponding lengths in the correct places. So the 3 is with the y, so we put that at the top of our fraction, and then here the 4 is with the 6, so that goes at the bottom. If I rearrange and solve this, which is multiplying by 6 on both sides, I will get y equals 6 times 3 over 4, okay, and that is 18 over 4, which is 9 over 2, and that's also 4.5. Okay, so our answer here is 4.5 centimeters. Okay, question number 7 says, at a nursery, the mean age of 4 children is 31 months. Katie joins the nursery. The mean age of all 5 children is now 30 months, so her age must be less than the mean. Work out the age of Katie. Now, I think it's useful to draw a picture of what's happening here. We know that there were 4 children, and if we were to add up their ages and divide by 4, that will give us 31 months. So there might be 4 values, so 4 possibly different values, and if we were to divide that by 4, we get 31 months. Now, later on Katie joined, but actually I can find what the sum of the ages of the 4 children are by multiplying by 4 to both sides here. So if I did 31 times 4, that will give me the sum of the 4 children's ages. So this would be equal to 31 times 4, which is equal to 124. So 124 months. So we're saying those 4 children, if we were to add up their ages, it will be 124 months. Katie now joins the nursery. The mean age of all 5 children is now 30. So for Katie's age, instead of using a box like that, I'm going to use K. So now we're going to actually use algebra for it. So 124, add Katie's age. Okay, so this is the sum of all 5 children's ages now. Divide that by 5 gives us 30. Okay, so we're going to solve that equation. Now, to solve that equation, we're going to multiply by 5 on both sides and then subtract 124. So if I multiply by 5, I will get 124 plus k equals 150. And now if I subtract 124 from both sides, I'm going to get k is equal to 26. So 26 months here. And as we expected, Katie's age is less than the mean of the first 4 children. Okay, question number 8. We have John chooses a number at random from the digits 1 to 4. Okay, and Matt also chooses a number at random from the digits 1 to 4. Write down the probability that the sum of the 2 numbers chosen is a 2-digit number. Well, the largest number we could have got is John getting 4 and Matt getting 4, and the addition of that is 8. Therefore, it's not possible. So the probability of that has to be 0. Question 8b now. Work out the probability that the product, so the multiplication of the 2 numbers chosen, is a 2-digit number. So if John chose 4 and Matt chose 4, that's 4 times 4, which is 16. If John chose 3 and Matt chose 4, that's 12. But John could have chosen 4 and Matt could have chosen 3, and that's 12. And then the next smaller number we could have got is 3 and 3, okay? And that makes 9, which is not a 2-digit number. So the possible combinations, if I put probability that John gets 4 and Matt gets 4, okay, so that's how I'm doing it. Add the probability that John gets 4 and Matt gets 3, and also add the probability that John gets 3 and Matt gets 4, okay? Now the probability So they said that John chooses a number at random, so it could equally likely be either 1, 2, 3, or 4. So the probability of John getting a 4 is a quarter, so it's a quarter times a quarter, because Matt also chose at random. We need this one again, a quarter times a quarter, and also again a quarter times a quarter. That's going to be 1 over 16. This is going to be 1 over 16, and this is going to be 1 over 16. Okay, and then we're going to add them up, and that's going to be 3 over 16. Okay, question 9. We have the area of an ellipse, width A and height B is given by, so we've got a formula for the area of an ellipse. The width they've called A and the height B, which goes like that. A rectangular photograph measures 15 centimeters by 10 centimeters. Okay, and I can see that there's an ellipse here as well. It is put into a frame as shown. The part of the photograph that can be seen is an ellipse. So this part here can be seen, and this is an ellipse. So we can find the area of that using this formula. And it says work out the percentage of the photograph that can be seen. So it's all of this part over the area of the whole photograph. Okay, so the area of the whole photograph is going to be 15 times 10. But I need to find the area of the ellipse and put it over what 15 times 10 is. So area of the ellipse here would be pi times 15 times 10 divided by 4. Okay, and then all of that I would have to say all of that divided by 150, or 15 times 10. Okay, and that will give me the decimal, and if I was to times that by 100, that will give me the percentage of the photograph that can be seen. So this is the area of the ellipse that I have here. Then I have that needs to be divided by the area of the photograph, and then if I was to multiply that by 100, that will give me the percentage. So if I work that out now, 15 times 10 times pi and divided by 4. Okay, so that gives me a value around 117.8097 and some more digits. Okay, I need to divide that by 150 and times it by 100. Okay, so I'm going to divide that by 150 and then times that by 100, and that gives me 78.5. So that gives me 78.5 to 1 decimal place. Okay, so we'll say 78.5%. Okay, so question number 10. It says, at a concert, 3 adult and 4 child tickets cost £23, and 1 adult and 5 child tickets cost £15. Work out the cost of an adult ticket and the cost of a child ticket. What we have is we haven't been told how much each adult ticket is or each child ticket, and it's asking us to find that. We need to make some equations and then use our equations to solve that. We can assume that the adult tickets in each combination were the same price, and the same we can say about the child tickets. So let's say the adult tickets, the cost of them, we're going to call it A, so 3A, and the cost of a child ticket we're going to call it C, 4C equals 23, and we also have 1A, or just A, add 5C equals 15. Now these are simultaneous equations that I need to solve, so I'm going to multiply my second equation by 3. So if I was to multiply this by 3, what I would get is 3A add 15C is equal to 45. Okay, I'm going to rewrite them here. 3A add 15C equals 45, and our first equation was 3A add 4C equals 23. Now I'm going to subtract them, and I'll be left with 11C here and 22 here. So therefore the cost of a child ticket would be 22 divided by 11, which is 2. Okay, and as the numbers here that I've used had the unit of a pound, therefore it's £2. To find the cost of an adult ticket, I'm going to use this equation because it looks the easiest to use. So one adult ticket at 5 times £2 is equal to £15, and 5 times 2 is 10, so this is the same as A plus 10 equals 15. Therefore, the adult ticket costs £5. Okay, so cost of an adult ticket, we can say £5, and cost of a child ticket was £2. Okay, so question 11, it says, a doctor claims that the probability of having regular illness is doubled if you have poor sleep rather than good sleep. Okay, so doubled. In a survey, 16% of people with poor sleep had regular illness. Okay, so in a survey, 16% of people with poor sleep had regular illness. Here are the results of for people with good sleep. So this is for good sleep. And it says, comment on the doctor's claim, you must show you're working. Okay, so the doctor's claim was that having regular illness is doubled if you have poor sleep rather than good sleep. So we've got good sleep here, and we've got a value for poor sleep. We can find the percentage of people who had regular illness here. Okay, so what we would do is add up all of these people and do 24 divided by that. So we have 276 add 24, and it's going to be 24 over 24 add 276. That is the same as 24 over 300. Okay, and then you can use a calculator. 24 divided by 300 equals 0.08, and that is 8%. So these results for people with good sleep, using these results, we've got 8% of people, 8% of the people who had good sleep had regular illness. The doctor's claim was that having regular illness is doubled if you have poor sleep rather than good sleep, and 16% of the people with poor sleep had regular illness. So it is actually what we found here. So it says comment on the doctor's claim. So the doctor is correct based on these surveys. Okay, and this sentence here is very important. This gives you a communication mark. Okay, you must write a sentence that either says the doctor is correct or incorrect based on the values that you got. Okay, question 12, we have a teacher asks Amy and Jack to convert 101,376 into standard form. Amy writes 10.1376 times 10 to the power 4. Criticize Amy's answer. Well, we know that this part here needs to be less than 10. It needs to be between 1 and 10, but less than 10. Okay, so 10 is not included. And here we've got a number that's more than 10. So we can say 10.1376 should be 1.01376. Okay, and then obviously that will change this part as well, but we'll just mention about that. Now we've got Jack writes 1.01376 times 10 to the negative 5. Well, this is clearly wrong because this is not even the same number that we had here. Okay, so this number is going to be 0.000, some zeros, and then all of these digits. So here it shouldn't be 10 to the minus 5. It shouldn't be 10 to the minus 5. It should be 10 to the power of 5. Okay, and that would have worked because then all of these digits would have come over the decimal point. Okay, so question 13 now. At a concert, the ratio of men to women is 5 to 3, and the ratio of women to children is 7 to 4. Okay, so this doesn't include men. And then show that more than half of the people at the concert are men. So we need a ratio that has men to women to children. Okay, so the ratio of men to women, so let's say M to W, is 5 to 3, and the ratio of women to children, now this time I'm going to put children here, so women to children is 7 to 4. Okay, now I can find an equivalent ratio to my first one, and like for example I can have 10 to 6, but that won't be helpful. But I can change this one as well. Now if I was to make this part here into its lowest common multiple, then I can have one long ratio that compares men to women to children. So we'll use 21. Okay, so this number here should be 21, and let's find those numbers. So to go from here to 21, it was a multiplying by 7. Okay, so I need to do 5 times 7, so times by 7, and that will give me 35 here. And to go from this 7 to 21, it was times by 3. Okay, so this one here was timesing by 3. 4 times 3 is 12. Okay, so my ratio is 35 to 21 to 12. Okay, so this is the ratio of men to women to children. Okay, and the question was, show that more than half of the people at the concert are men. So this 35 needs to be more than these added together. Okay, so we can say that 35 is greater than 21 add 12, which is the same as 35 is greater than 33. Okay, so question 14, we have used the quadratic formula to solve this equation, and it says give your solutions to 2 decimal places. Okay, so in other questions it didn't tell us to round to a certain place, but here they're telling us 2 decimal places. So what I can do is I can write the quadratic formula, but that doesn't give me any marks. Okay, so if I was to write x equals negative b plus minus square root of b squared minus 4ac over 2a, that does not give you any marks. Now substituting the values from here correctly, that does give you marks. Okay, and also I wanted to say that we could have been given a quadratic equation where it wasn't equal to 0. So for example, we could have had 5x squared add 11x equals 2. And that's not a form that I can use for the quadratic formula. I need it to equal to 0 to be able to do that. So this is in a correct form. Okay, so we can just use that. Also, anytime you're substituting a negative value, it's always a good idea to put brackets around it, and you should. Okay, you really should, because sometimes if you don't, your calculator can give you the wrong answer for that. So now we're going to substitute, and that's going to give us our first mark. So negative 11 plus minus square root of 11 squared take away 4 times 5 times negative 2 in a bracket, and then this is going to be over 2 times 5. Okay, now you can now type this whole thing into your calculator, once with a add here, once with a take away, and you'll get your two values. Or you can actually simplify it down a little bit, okay, so that you have to type out less in your calculator. But I would recommend that you just type this into your calculator as you see it here. Okay, as long as you've got your negative value in a bracket, you shouldn't have a problem with this. Okay, but I'm gonna make it simpler. So I'm gonna say that's equal to negative 11 plus minus square root of 121, and here I've got 4 times 5 times negative 2. So 4 times 5 is 20. Times by the negative 2 is negative 40. Taking away a negative 40 is like adding a 40. So add 40. And that's going to be over 10. Okay, and then I can simplify a little bit more. Negative 11 plus minus square root of, that's 161 over 10. So now I'm going to input it twice into my calculator, once with the add, once with the take away. So I've got negative 11 add square root of 161, and that divided by 10, that gives me, so one of the values I'm going to have is x equals 0.17 to 2 decimal places, and the other one, if I was to do it with a takeaway this time, so negative 11 take away square root of 161 and divide that by 10, and that gives me x equals negative 2.37. Okay, so these are my two values, both of them rounded to the second decimal place or two decimal places. Okay, question 15, we have the universal set contains the whole numbers 1 to n, and n is an even number greater than 100. O is the set of odd numbers, so all of the odd numbers. P is the set of prime numbers. S is the set of square numbers. Explain why there are no numbers in P intersection S. So we can't have any numbers that are prime and square numbers. That's what this is telling us. So prime numbers have two factors. Square numbers that are greater than 1 have at least three factors. The square number of 1 has one factor, but that's not prime, so that's not included. And every other square number has at least three factors. For example, it will have the factors 1 and itself, and also the number that you squared. Okay, so square numbers that are greater than 1 have at least three factors, and 1 has only one factor. And we can say prime numbers have exactly two factors. Okay. Question 15b. How many numbers are there in O union P? So O is the set of odd numbers, so all of the odd numbers, and we have to also include the prime numbers. Circle your answer. So the universal set contains the whole numbers 1 to n. N is an even number greater than 100. So for example, if n was, let's say, 102. So if it was 102, there will be 51 odd numbers and 51 even numbers. Okay, so half of them would be odd, half of them would be even, and that will be the case for any number that we take for n using these conditions. So half of the numbers are odd, half of them are even, and we need it to also be prime number. We also need it to be a prime number. Now, prime numbers start with 2, which is even, and all other prime numbers are odd. So when we count the odd number, when we count all the odd numbers, we will count every prime number except for 2. Okay, so that's only one more. So half of the numbers are odd. Okay, so just O is n over 2. And if I include all of the prime numbers, I have to also include 2, which is one more. So n over 2 add 1 would be our answer here. Okay, question 16, we have a calculator gives a value of pi as 3.14159, and an approximation for pi can be found using this. Show that the value of the approximation is within 0.01% of the calculator value. So it's of the calculator value. So this is our main value, and we need to know what fraction of this is this. Okay, so let's write that out. So we're going to have square root of 40 over 3 take away square root of 12. That as a fraction of 3.14159. Okay, so I can work that out, and then I'll times it by 100, and then I'll know what percentage of that this is. Okay, so let's work this out first. So this is square root of 40 divided by 3, take away square root of 12, and then I need to divide that by 3.14159, and that gives me 0.9999819 641 3, 4. Now if I times that by 100, I get my percentage. Okay, so this is equal to 99.9981964,134%. Now, if I was to subtract this from 100, I would be able to see how we're doing with that. Okay, so 100 take away that. So 100 take away 99.9981964,134. So do 100 take away. It is equal to 0. Remember here we're working in percentages. Okay, so this is a percentage. The 100 is 100%. Okay, so my answer here is also a percent. So this is equal to 0, 0, 1, and then 8, 0, 3, 5, 8, 6, 6. Okay, so we were told show that the value of the approximation is within 0.01%. Now, if it was more than that, then it's not within 0.01%. If the difference was more than that. Now, this difference is actually less. Okay, so this is less than 0.01%, so we're fine. So we can say that 0.001803586 is less than 0.01, so we're fine. Okay, question 17, we have that the region R satisfies the three inequalities that are given here. Show the region R on this grid. So our first inequality says x is more than negative 3. Okay, notice how these are less than or equal to and more than or equal to. So x is more than negative 3. So x is negative 3 here and anywhere along the line there. Okay, but we can't have x is negative 3. It has to be more than negative 3. So this is our boundary line, but we are going to use a dotted line to represent that for us because we're not including negative 3. Now you should do this with a ruler, okay? And then we can say x has to be more than negative 3, so that's values on this side, okay? What I like to do is I like to put a little arrow to show that this is the side that I'll be looking at. Now for the next inequality, x plus y is less than or equal to 2. The boundary line would be x plus y is equal to 2, and that would be a solid line because it can be equal to 2 here as well. So that would be, we can say x is 0, y would be 2 because 0 add 2 is 2. Or y could have been 0 and x 2, okay? Or we could have x is negative 2, y is 4, okay? And that's 3 points. I can use my ruler and draw a line through them, okay? And now I need to find is, so does this inequality represent this side or that side? Now, it's best to check some values. Okay, so if I was to check this value there, x is 2 and y is 5. So 2 add 5 is what I need to do. 2 add 5 is 7. 7, is that less than or equal to 2? No, that's more. Okay, so this side is not allowed. This side should be allowed, but let's just quickly check. Let's use x is 0, y is 0. So 0 add 0 is 0. Is 0 less than or equal to 2? Yes, it is. So this is fine. Okay, so the arrow is going to be pointing this way for me now. Now the last one, we have y is more than or equal to x over 2 take away 1. So the boundary line is y is equal to x over 2 or half x take away 1. The y-intercept is negative 1 there. Okay, so if x was 0, y is negative 1. So that's there. And then it's best to take even values of x, okay, just to keep them integers. So if I use 2 here, so x is 2. 2 divided by 2 is 1. 1 take away 1 is 0. So this is another point on this line. Let's use negative 2. So negative 2 divided by 2 is negative 1. Negative 1 take away 1 is negative 2. Okay, so we have negative 2, negative 2. That's another point. So you can use your ruler again. So draw this line. And now we need to know, is it on this side or is it on this side? Okay. So let's look for some integer coordinates, like for example here. So here we have x is 1 and y is negative 2. Okay. So actually let's use even digits. That's easier. So let's use x is 2 and y is negative 2. So x is 2, so 2 divided by 2, that is 1. 1 take away 1 is 0, okay? So is 0, so y we said was negative 2. So is negative 2 more than or equal to 0? Okay, I'm just going to write this down because it sounds a little complicated. If what I'm doing is I'm checking this point here, so I'll mark it in a different color. So I'm checking this point where x value is 2 and y value is negative 2. So if I use this inequality, let's see if this inequality is true for this point, okay? So if I substitute the value of y, that's negative 2. Substitute the value of x, that's 2. So 2 over 2, take away 1. So let's see if it's true. Negative 2, is that more than or equal to, that's going to be 1, take away 1, which is 0. So is negative 2 more than or equal to 0? It's not equal to 0. So is negative 2 more than 0? No, it's not. It's less. So this is a point that's not included in this inequality. So this side doesn't work. That side should work, but let's just check. Okay, so let's check this this point here. So this point is x is negative 2 and y is 0. Okay, so let's check that one. So this is x is negative 2 and y is 0. Again, I'm going to substitute into my inequality. So that's going to be 0 is more than or equal to negative 2 over 2, take away 1. Let's see if that's true. So 0 is more than or equal to, so that's negative. So this would be negative 1. Take away 1 is negative 2. Okay, so negative 2. Is this true? Is 0, it's not equal to, but is 0 more than negative 2? Yes, it is. So this point is fine. So it's that side of the line that I'm looking at. Okay, so it's this side of the line that I'm looking at. So that said, we need to now show the region R on the grid, and the region R is here. Okay, so that's on the right hand side of the dotted line. It's below this line and it's above that line. All of this part here is R. Okay, for question 18, we need to rearrange this equation here to make D the subject. I can see that I have a D once here at the top of the fraction, once here at the bottom. We need to bring D together in one place. Okay, so if I multiply this side of the equation and that side of the equation by D plus 3, I will lose the fraction here and I will have it over there. So I will have D plus 3 on the left hand side. So we will have C times D plus 3 is equal to 4 take away D. Now if I was to multiply this out, because I can add D to both sides, but I still need to bring it together somehow. So let's multiply this out. So CD plus 3C, I'm going to say is equal to 4 take away D. Now I'm going to add D to both sides. Okay, so everything in D, I'll bring it to one side, and the 3C, I will take it to the other side. So subtract 3C from both sides and add D to both sides. That will give me CD add D equals 4 take away 3C. Now, this I can't simplify because I don't have a value here. I've got C. Now, there is another technique we can use in algebra that brings the D together. So I've written D twice here in this equation. I can write it once if I was to factorize it. Okay, so if I factorize it, I write D bracket C plus 1. Okay, and that's going to be equal to 4 take away 3C. Now, this is really the main step when you're rearranging equations like this. We've got D in two places. We can't add them because we don't have a value for C here. This one is a 1D or just D, but this one's a C, so we can't add them or simplify them like that. But if we were to factorize them, can you see how we've got D written only once in this equation? It was written twice there, and twice there. But now I've achieved something where it's written only once, and I've got D times C plus 1 is equal to 4 take away 3C. Therefore, if I was to divide both sides by C plus 1, I will get this C plus 1 will cancel, and I will have divide by C plus 1 on that side. So what it would look like is divide by, let's put it in brackets, C plus 1, and divide by C plus 1 here, okay? And then I know that this and this will cancel, and I would be left with D equals 4 take away 3C over C plus 1. Okay, so we've rearranged this equation to make D the subject here. Now, question 19. Which of these points is not 5 units from the point 0, 0? Circle your answer. Well, that's clearly 5 units from 0, 0. This one we're not sure about. This one you might know right away, but let's say we're not sure about that. And this one is definitely 5 units away. Now these ones, okay, if I was to draw a sketch, now the point 0, 0 is here. If I go 1 and 4, okay, so maybe around there. Now you can think of this like a right angle triangle we've done. Okay, so we've got 1 and 4 there. And also if we were to say 3 and 4, so 3 and 4, which is about there, let's say, okay, and we have a right angle triangle like this. Now you might know that the values 3 and 4 in a right angle triangle, okay, in a right angle triangle, if we were to apply Pythagoras theorem here, this value would be 5. Okay, so 3, 4 and 5, one of the Pythagorean triples. So this is actually 5 units away, so this length here is 5, and this length we can't say is 5. Okay, so the question was, which of these points is not 5 units from point 0, 0? It is this one. Okay, so question number 20, we have the square of x is 7, so therefore x must be square root of 7. And then we've got circle the value for x cubed. So x is square root of 7, so we have square root of 7, and that's going to be cubed, and that's equal to square root of 7 times square root of 7 times square root of 7. I know that square root of 7 times square root of 7 is just 7, and then I'll have a square root of 7 left, so that will be 7 root 7 is this one. Question 21 now. W, x and y are 3 integers. W is 2 less than x. Okay, so W is 2 less than x. Now this is really an equal sign. Okay, so we have W equals 2 less than x, so that will be x take away 2. Okay, and that equation is coming out of this sentence here. W is, so W equals 2 less than x. 2 less than x is x take away 2. And we have y is 2 more than x. So we've got y equals 2 more than x, so that's 2 plus x, or x plus 2. And we have to prove that wy plus 4 equals x squared. Now when you get, for most proof questions, you try and do whatever you can with whatever information that you have. So in this case, we have these two sentences, and we've already made equations from them. I can see that there's a wy here. Okay, so if I multiply wy, I will get I will get something, and I know that I'll have wy then. Okay, so if I do wy, if I say wy, what is that going to be equal to? Well, that is x take away 2 times, let's say x plus 2 this time, x plus 2. So then I know, okay, so remember, in the proof question, we are just trying to do whatever we can. So we looked at this wy part. The x squared part is difficult, because if I was to rearrange that and square it, I will only get something in terms of w. If I was to do something similar here, so for example, take away 2 on both sides and then square both sides, I have something in terms of y, but I need w and y in my equation. And look at this, I've actually got this now. I've got w, y, and I've got x in my equation. So I think that this should be, we should be able to rearrange this and make it look like that. Okay, so multiply it out. So we have wy equals x squared, take away 2x, add 2x, and take away 4. So then we have wy equals x squared, take away 4. And now you can see that if I was to add 4 to both sides, it would look like that. So the next line is wy plus 4 equals x squared, which was what was required. Okay, question 22, we have ACB is a straight line. So ACB is a straight line. and A is the point 0.8, so 0.8, and B is the point 40, 40 is there. C is the midpoint of AB. C is the midpoint of AB, so I can find the coordinates of C. Line DCE, so this line here, is perpendicular to line ACB. When they're talking about perpendicular or parallel, and it's a question on coordinate geometry like this, what they mean is, their gradients will multiply to -1. Okay, so if you know the gradient of this, you can find the gradient of that one. Also, in geometry questions, and it doesn't have to be coordinate geometry questions, they often write the information in lines like that, and sometimes you sort of have to tick these lines off. Have I used this fact? Have I used the second line? Have I used the third line? Have I used the fourth line? Okay, so sometimes when you're stuck doing this, think about what you can do when they tell you A is the point this and B is the point that. You might need to combine it with another line, and for example C is the midpoint of AB, and then you can see you need to use A and B to find the value of C, and they told you C is the midpoint, so we can find that quite easily. The question is, work out the equation of line DCE. So work out the equation of the line DCE. So we're going to need a gradient, and we're going to need one of the points that's on the line, and we can see that this point C is on the line. So if I know the coordinates of C, and if I can find the gradient of this, then I can find an equation of this line. Remember we said that the equation of this, if I was to know the gradient of this, not the equation, the gradient of this, I can find the gradient of this, and we can do that because we've got the coordinates. Okay, so let's start by finding the gradient of AB. So that would be difference in y, so 8 take away 0, 8 take away 0 over 0 take away 4. Okay, and that will give us 8 over -4, or -8 over 4. That's going to give us -2. So the gradient of this line here is -2. Now I know that the gradient of this has to, when I multiply it to this, has to make -1. So -2 times the gradient of the line DCE should equal to -1. Okay, so therefore I know that this will have to be a half. So if I was to divide both sides by -2, I will get -1 divided by -2, which is a half. Okay, or you can think of it, a lot of people like to say the negative reciprocal of that. Okay, so the value here is a half. Okay, and that value is the gradient of this line. So now I know the gradient of this line. I need one of the points on this line to make an equation. Okay, so I need an x value and a y value for one of the points, and we can find that here. So I've used the fact that line DCE is perpendicular to line ACB. Okay, now we're going to use the fact that C is the midpoint of AB. We've already used this once, but we're going to use it again. Okay, so C is the midpoint of AB. So let me just take this one off as well. C is the midpoint of AB, so therefore the value here would be 2, the value here would be 4. Okay, so the coordinates for C would be 2, 4. Okay, that's one way to think about it. The other way would be add up the x values, which is 4 and 0. Here we've got 4 and 0, and divide by 2, you get 2. Add up the y values, 8 and 0, divide that by 2, you're going to get 4. So 2 and 4 are your values. So 2 is my x value, 4 is my y value. Now I'll use the form y equals mx plus c. Y equals mx plus c. The value of y that I know here is 4. Okay, and the value of x will be 2, and the value of m, which is the gradient, is going to be a half. Okay, so if I use those values in this equation, that will give me the equation of this line. I can find what c is from there. So we're going to have 4 equals half times x is 2, and then add c. Half times 2 here is 1, and if I was to subtract 1 from both sides, I'm going to get 3 on this side is equal to c. So c is equal to 3, and I'm just going to rewrite my equation now that I know c, and I know what m is, I'm going to write my equation in y and x. So we're going to have y equals, m is a half, so half x, and c is 3, so add 3. Okay, and that's our equation. Okay, question 23. We have a triangle here. Kernow is using trigonometry to work out the size of angle x. Okay, to work out the size of angle x, he assumes that the angle ABC is a right angle So ABC, this angle here, he's assuming is a right angle, which would make this a right angle triangle. In fact, the size of angle ABC is 85. So it's not 90, it's 85. Okay, so it's not a right angle triangle. What is the effect of his assumption on the accuracy of his answer? You must show your working. Okay, so he assumes that the angle is a right angle here. So therefore he's assuming this is a right angle triangle. Now if he assumes that this is a right angle triangle, to find this angle, we're going to say, okay, sine x is equal to 6/10. Now, actually, this triangle is not a right angle triangle, and this angle here is 85. Now, when we have a triangle that's not a right angle triangle, we don't use SOHCAHTOA, or we don't use sine of this angle would be opposite over hypotenuse and so on. We're going to have to use the sine rule, okay? So sine, this sine of this angle over 10 is the same as sine of x over 6. Okay, so what we can do is we can first work out what x is using his assumption, and then work out the actual value of x. And it says what is the effect of his assumption on the accuracy of his answer, and then we can say how it's different. Okay, so the first thing we're going to do is let's use his assumption first. Okay, and let's say as he's assumed that was a 90-degree angle, so that means sine x would equal to 6/10, and to find the value of x he would do the inverse of sine, and 6/10 is 3/5. Okay, so that will give him his value. I'll work that out in the calculator once I've done the other bit. So the other way would be to say that this is 85. So now I'm going to use the sine rule. So sine 85 divided by 10. So sine 85 divided by 10 is equal to sine of x divided by 6. Sine of x divided by, sine of x divided by 6. Now there is another form for the sine rule, which is to have it as 10 over sine of 85 equals 6 over sine of x. But as we're finding the angle, it's easier to have the angle at the top. Okay, so whatever you're finding, or whatever the unknown is, have that at the top, and it's easier. Okay, so what I can do to rearrange that is times by 6. Okay, so sine x, so I'm going to write it this way now, sine x is equal to 6 times sine of 85 over 10, and that would mean x equals inverse sine of 6 sine 85 over 10. Okay, so I'll work out the two values. Okay, this value is the assumption, using the assumption that he made, and this is the actual value of x. Okay, so let's do this one first. So inverse sine, and it's 3/5. That's going to give us 36. Let's have 36.86986. Okay, and I've just rounded out to there. And the actual value, which is this one, using the angle as 85, we're going to have inverse sine of 6 times sine 85 over 10. Okay, and that value is 36.7014. we had 1, 2, 3, 4, 5, 6, 7 decimal places there. Let's use 7 decimal places again. 70655, and then it will be 1 3. Okay, so I can see that what is the effect of his assumption on the accuracy of his answer? Well, on the accuracy of his answer, I can see that to the nearest whole number, he's fine. No, he's not actually. If you round this to the nearest whole number, you get 37, and no, round this to the nearest whole number, you get 37 as well. So the accuracy of his answer to the nearest whole number is fine. To one decimal place, it's not fine. Okay, so the accuracy of his answer, the accuracy of his answer is correct to the nearest whole number, but incorrect from the nearest tenth. Okay, I'll just put it like this. Okay, so we can see that if we were to round this to the nearest whole number, we'll get 37. Round this to the nearest whole number, we'll get 37. So if he made this incorrect assumption and he found the value of x and he rounded it to the nearest whole number, he would have got 37, which is what he would have got if he had actually calculated it properly. Okay, but if he was to round to one decimal place, he would have got 36.9 here, and here he would have got 36.7. So then it would have been wrong. Okay, so that's what we said here. Okay, question 24 now. We have AED is a straight line. AED is through here. AE is A plus 3B, and EB is negative A plus B. Now, this is different from how we've seen it often in the past, where each of the vectors that are defined, they will just have A or 2A or something in B, but it won't have both A and B, okay? So it's slightly different question here. It says work out the vector of AB. Okay, so work out the vector of AB. Now, in vectors, what we should be thinking about is paths, and paths that we have, paths that we don't have. Is there another path to get from A to B? Okay, I can see that that's one of the paths, but there's another path going this way, and what I can do is I can just go along there. I can say I'll add that to this, okay? So I'm going to say A, add 3B, and I'm going to add to that negative A, add B, which is the same as saying A, take away A, add 3B, add B, and that's going to be 4B. Okay, so the vector going from A to B is 4B. Question 24B now. Also ED, so ED is here, is a third of AE, so it's a third of that. Okay, and DC, which is here, is negative a third of A. Okay, so negative a third of A. So that actually means A goes that way. Okay, and the negative of that is going to come this way. Prove that EC is parallel to AB. Okay, so AB is here, EC is there. Now we need to show that they're going in the same direction, which would mean they both need to be in terms of the same thing. So here I can see that this is in terms of B, so I should get this to be in terms of B somehow. And if this is a multiple of that, then we can say that they're parallel. Okay, so I've got EC here. Now remember what we said, we're looking for paths. So EC, we don't have anything here, but we've just been told what ED is, and we've also been told what DC is. So this is another path to take us from E to C. Okay, so we're going to go that way and then add it to that. So ED is a third AE, so a third times AE. So ED is equal to 1/3 times A plus 3B. I'm just going to multiply that out. So I'm going to say this is A over 3, and then a third of 3B is just B. Okay, so add B. And DC, they've given it like this, so negative a third A. So I need to do this, add that, So I'm going to have A over 3, and this is going to give me EC. So EC is equal to A over 3 add B, and then I need to add to that negative a third A. Okay, so that's going to be the same as, so this is a third A, and if I'm sort of, this would mean taking away a third A. So add, I've got a third A there, I'm taking away a third A, they cancel out, and I'm left with just B. So the vector EC is B. Okay, so the vector EC is B. So I've got 4B here, and I've got B there. Now I can see that they must be going in the same direction, as this is a multiple of that, and if that's the case, then these have to be parallel. Okay, so we can say that 4 times EC, should put an arrow here, that was AB and this was EC, so 4 times EC is equal to AB, and then you can say as let's write it down. So as AB AB is a multiple of EC, they are parallel. Okay, question 25, we have the time of each swing of a pendulum with length L is t seconds. Okay, so actually think about what's happening. So it's a pendulum, and the time of each swing with length L is t seconds. T is directly proportional to the square root of L. When L equals 64, T equals 1.6. Work out the value of T when L equals 132.25. I think this is quite an easy question for it to be a 5-mark question. Okay, so we just follow the process of how we work with direct or indirect proportion, in this case direct proportion, and it's directly proportional to the square root of L. So that's the one bit that we need to be careful with. So we have T, so we've got T, and what I like to do is I like to go straight into the equation. So T is going to be equal to a number K, or the constant of proportionality, times the square root of L is. Okay, so now I've got some values. So L is 64 when T is 1.6. So I can say 1.6 is equal to K and then square root of 64. And to find K, I will say K is equal to square root of 64 is 8. So we'll say 1.6 divided by 8. Okay, 1.6 divided by 8. If you put it in your calculator, you will get 0.2. So this is 0.2. Next thing is, the next thing always, once you've found K, always rewrite your equation with K in there. So now I'm going to say T equals 0.2 times square root of L, and they're asking find the value of T when L is 132.25. So T equals 0.2 times square root of 132.25, and just use a calculator for that. So that's going to be 0.2 times square root of 132.25, and that's equal to 2.3. So this is equal to 2.3. So it'll be 2.3 seconds. 2.3 seconds. 2.3 seconds when the length was 132.25 centimeters. Okay. Question 26 now. The graph with equation y equals x squared is translated by vector 2, 0. So it's moved to right. Circle the equation of the translated graph, and we've got these equations here. So let's think about what the graph would have looked like. So the graph of y equals x squared looks like that, and that being y and that being x. And then if I was to translate it 2 to the right, it will end up somewhere like that. Okay, so that was at the orange, and here we'll have the value 2. So I can see that the roots of this equation here is 2. Therefore, it would be it's a double root here, so it's going to be x take away 2 squared. It will be this one. That's one way you can think about it. The other way is if you were to think of this like a function. So the function is x squared, and then it's been translated 2 to the right. Therefore, this part here, you would have to take away 2 inside here. So you would have to say x take away 2 inside there. So that's the other way you could have thought about it. Okay, question 27, we have here's a sketch of a speed time graph for part of a journey, and the average speed from 0 to t seconds was 7.2 meters per second, and it says work out the value of t. So we've got the speed here. Now the speed is given in meters per second, and here I have time in seconds. So the units are consistent, okay, so we can work with that together. If we just think about what this graph means, we've got the speed is increasing here, so this means acceleration from here. And then we've got this part here where the speed is constant. The speed is 9 meters per second. And then we've got this part here where the speed is decreasing from 14 seconds to t seconds here. Now they're saying work out the value of t. Now the value of t, the t here represents the time for the entire part of this journey. Okay, so this whole part, the time for that is t. We've got the average speed here given, and we can actually find the distances from finding the area under this. So let's just think about this middle part for a bit. So from 8 seconds to 14 seconds, this object was traveling at 9 meters per second. So 9 meters per second. 9 meters per second means 9 meters for every 1 second, or 9 meters per 1 second. And from 8 seconds to 14 seconds, that's 6 seconds, okay? And for each of those seconds, it was traveling 9 meters, okay? So 9 meters times 6 would give me the distance in meters here. So we've got 9 times 6, which is 54 meters here. So this part of the journey here was 54 meters. And what you would also notice is that this length here is 9, that length is 6, and 54 is the area of this rectangle here. Now finding the area under a speed time graph gives you the distance. Okay, so we can find the area here. This is going to be 8 times 9 divided by 2. Okay, so let me just write the other one as well. So we've got 9 times 6, which is 54, okay, meters. And then we've got half times 8 times 9. Half times 8 is 4, 4 times 9 is 36, so that's 36 meters there. And this last part here is a trapezium. Okay, so trapezium there, and these are your parallel sides. Now I can see that this side is 9, this length here, because it goes from 0 all the way up to 9, and this height here is 7. So these are your parallel sides. Half times, in brackets, 9 add 7, and then times by this length here. Now this length here we actually don't know, okay? So the best we can do here is give an area in terms of t, or give an area in terms of t in algebra, okay? So this length here, we can say what it is in t, because 0 to t is all the way up to there, and if I subtract 14 from that, I will get this length here. So t take away 14 is there, t take away 14, okay? And then I can say, okay, I'm going to do half times the two parallel sides added together, so 9 add 7, 9 add 7, and I'm going to multiply that to t take away 14, so this has to be t take away 14 in a bracket. Now I've got 54, I've got 36, and I've got this for the distance. Okay, so my distance isn't this can simplify, okay, so I'm going to simplify that, but my distance isn't a number. If I had just had a number, I would just use that number and divide by 7.2. Okay, let me just simplify that first. So here we're going to have half times 9 and 7 is 16, so that's half of 16 is 8. I've got 8 and then t take away 14. Okay, now what we can do is, as distance divided by time gives us 7.2. So the total distance is 36, add 54, add the area of this bit, which is here. And if I was to divide that by time, I know that that should give me 7.2. So that gives me an equation. Okay, so if I said 54, add 36, add 8t take away 14, and divide that by time. So the time for the entire part of this whole part of the journey is t. Okay, so divide all of that by t. So the average speed from 0 to t. So divide all of that by t, you will get 7.2. Okay, so divide that by t, we will get 7.2. Now notice how here we had a problem with writing one of our areas in terms of t. Okay, so in algebra, but then we've got more information here. Okay, and that information, by them telling us the average speed from 0 to t seconds was, so that was is our equal sign, 7.2 goes there. Okay, and average speed, distance divided by time. Okay, now what I have is I have an equation with the unknown t. Okay, I can rearrange this and then solve it for t. Okay, and that should give me the value, work out the value of t. So that will give me the value of t. So times both sides by t, and I'm also going to multiply out this bracket. So, and also I'm going to do 54 at 36. So 54 at 36, that's 90. 90, add 8t, take away 8 times 14, that's 80, 80 and 32, so that's going to be 112. And if I multiply this side by t, I lose the fraction, and I have 7.2 times t on that side. So here I'm going to get 7.2 t. Okay, now what I need to do is so rearrange this so that the numbers go on that side and the t comes on this side. So I'm going to subtract 7.2 t from both sides. That will leave me with 8t take away 7.2 t is 0.8 t. So 0.8 t is equal to, so I'm going to add 112, and then I'm going to take away 90 from that. That's going to give me 22. So 22 on this side, and 0.8 is 4 over 5, so times that by 5 and divide by 4, or just do 22 divided by 0.8, and that will give me what t is. So t is equal to 22 divided by 0.8, and I'm going to use my calculator for that. So 22 divided by 0.8 gives us 27.5. So this is 27.5 seconds. Okay, so t was in seconds here, and what we did is we just did 22 divided by 0.8 gives us 27.5 seconds. Okay, question 28, we have for all values of x, we have this function, so fx equals 4x take away 3 over 5. Work out the inverse function here, so the inverse function of f here. So I can see that this is actually quite an easy one, okay, because I can see that from x I need to first times by 4, then take away 3, and then divide by 5. Okay, so the inverse function would go the other way around, so the other way around with the opposite operation. So I said divide by 5 last, so it's going to be times by 5, then add 3, and then divide by 4. Okay, so it will be x times 5, which is 5x, add 3, and then divide by 4. But there is a method that we use for this, okay, and I'm going to show you that now. We replace the fx with y. So the y represents the output, okay, so fx normally is your output, y now represents the output. So y equals 4x take away 3 over 5, okay? And what we need is, we need a function, the inverse function, which when you know what the output is, which is y, it equals the input value, which is x. So we need to rearrange this and make x the subject. Okay, so first step is to times by 5. So 5y equals 4x take away 3. Then we're going to add 3. 5y add 3 equals 4x. And the last step would be to divide by 4. So 5y add 3 divided by 4 equals x. Now, remember, we said the y was our output. Now, here's a formula that gives me my value for x. Now, x was our input and y was our output. So it gives me my value for the input when I know what the output is. So if I was to know what the output is, I just work this out and I get my input value. Okay, and the main function, it takes me from the input value, which is x, and it gets me my output, which is f of x, or here we called it y. So this is a new function now, okay, and we're gonna call it f, so f -1 like that, and x. So this is my new function. Now functions are written in terms of x. So my function is this. Okay, so when I know that what the output is, I put it into here. And functions are written in terms of x, so I'm going to replace that y with an x now. Okay, so and because it's a new function, I'm not going to call it this anymore. I'm going to call it this. Okay, so this is going to be equal to 5x add 3 over 4. Okay, and that's our answer.